Hello everybody. Hope you guys are doing well. So today we will be talking about function calling and how why does it work, and we'll see some more examples, and we'll write code how to do calling, so that ultimately it's the code, right, that we are most concerned about. So okay, so yeah, so we said that first functions are higher order functions are so functions are basically higher order citizens, right? Basically they are functions are considered as first class citizens, and they are nothing but, or they can be stored like objects, right? So basically you can store functions like object. Now let's see how higher order functions work, and let's see like the difference between higher order functions and normal functions. Like for example, in C language as well, you have functions, right? So we'll see what is the difference. Well, this is basically how my node engine looks like, right? So basically, this is my virtual machine. This is basically going to convert my code into a machine language. Now here is where, so for that time to happen, code has to be taken from the memory, right? This is basically my RAM, which will be then go to JVM, and then we'll have machine or byte code being available. Now in this memory itself, functions are going to be stored, right? So this memory, so this is a more bigger example of how memory is. So basically you have different types of areas in the memory. So one area is basically called as heap area, right? So as we know, as we saw in OP languages, then objects are generally stored in the heap area, right? So basically, if anything is an object, then it will be stored here. So first we said that functions are objects, right? So basically, functions are our objects. That means they will also be present or stored in the heap area itself. Now, so this is how my functions will be stored in JS or JavaScript. Now let's see how it happens in C. So now when we mean that my function is stored in heap area, what basically mean is everything. Basically, the local variables declared inside the function, and all the function logic will also be present in my heap area, right? This is how my function works, right? So basically, my function will contain all the variables, and it will also contain the code logic, right? Basically, the logic present inside the function. So this is going to be stored inside the heap area. Now let's see in programming languages like C, right? So in languages like C, it's what do you say, a structured programming language, right? So basically, the first function that we go is mean, and then when we encounter a function keyword, we go and create a stack in our or a stack frame in our call stack. Now this stack frame is basically will contain all the logic that is needed for the variable, right? The moment this function is executed, it is taken out of the stack, and then so you have something called as stack pointer, right? Basically that keeps a track of top of stack. So the moment this goes out, then my top of stack will go to this main function, and the moment the main is taken out or execution is complete, the program will end, right? So what happens is when this stack frame goes out, all the function logic or all the variables and the any other thing associated with that function will also be removed from the memory, right? So once the execution is done, this is taken out from memory, so that now we do not have access to this function, right? Its execution is completed. Now the stack pointer will move from here to here, and now my stack pointer is going to point to the variables declared. And so this main is going to have all the variables and the local functions declared in here. So once that execution is done, again that will be taken out of from stack, and everything that is all the logic and variables declared along with it will be removed. So now let's see how let's see the difference between like C and how does it happen when functions become higher order citizens. So basically objects are stored in my heap area and functions are first class citizens, which means that they are present in the heap area in the memory, right? So basically heap area, so if there is a function, so that function will all contain all its local variables. So you have the local variables declared, and not only that, along with the local variables, you have all the methods as well. Like the method for the variables will also be present in here, right? Local variables plus you have the logic. This is all stored in the heap area and is referenced by this function. Now when are objects removed from the heap area? So the objects are removed by so there is something called as a garbage compiler, garbage collector, which take care of this freeing memory in my RAM, right? So whenever it sees there is something that needs to be freed, the garbage collector responsibility is to free it from the RAM. Now see the local variable. Okay, so now what is going to happen is, when will the garbage collector free it? So that is the question. Now objects are removed from the memory by the garbage collector. Basically, it uses the sweep in mechanism to so it kind of works on a algorithm basically, which is sweep in and to remove the objects, right? Now what is going to happen is, in this sweep in sweep out algorithm, the way it is going to work is it is going to mark it is going to mark the functions and check if the do we have a reference to this function. The moment the reference to this function is lost, that function will be marked as sweep out and then it will be removed from the garbage collector, right? So now let's see a function, right? So since we are dealing with higher order functions, we can return a function as well, right? So now we call this outer, so this is going to start the execution, right? So the moment we reach her, so basically a return statement, right? So this is basically going back to the colon. Now what has happened is the function execution of outer has been completed, right? So when we have in a return statement written, statements below it will not be executed, right? Only statements above it will work. This will come out of the will be coming out of the a function, right? So basically now for us to access this inner function, we need this function to be working, right? So this has to be present in the call stack and it has to be currently worked upon. Only then you can reach this statement. The moment we encounter this, we have come out this and everything has been taken out. So now we can no longer access this function, right? So this is what the sweep in mechanism does. So when the reference is lost or when we cannot access the outer function, then we say that then we say that the garbage collector will come and collect this function out. So basically, once the outer function execution is over, the reference to the inner function is lost and now it can be garbage collected, right? So we cannot no longer access this. Now when will be the outer function, or when that will be garbage collected? So the outer function will be garbage collected when we lose the scope to this, right? Now when we lose the scope to this is, what if this function is used in some other function, or what if there is a very global variable which is referencing to the function. So when this is assigned to a global variable, the global variable is still maintaining its reference, right? So that the outer function is not removed from by the garbage collector because the reference is still present here. So this is the difference, right? So using this, what we can say is, as long as this outer is going to be there, it is going to maintain all the logic or all the lines inside the function, right? It may not execute it, but it will still maintain it unless and until it gets the logic will be retained here. So this is how a function works as a closure, right? So a function closure is basically something that is going to retain the scope, right? Because these are in the heap area, so the scope is getting retained. Hence we say these are closure functions, right? So closure functions are those functions basically which retain the state in where they are declared, because the outer function might will be an object and will be stored in an heap area. So now let's see one like popular use case, right? So where can we use closures? So the advantage or one major or one major use case for using closures is basically you can use closures in for performing function currying, right? So let's see what do you mean by function currying. So function currying is basically instead of making multiple calls, so for example, suppose if you want to uh, so instead of so what does currying say? This is a mathematical concept, right? Currying says now instead of passing all the arguments at once, we make multiple function calls. So what does it say? Um, and we use the closure to our benefit. So instead of passing all arguments at once, we will make multiple function calls, and each okay function and each call will return a new function that accepts the next argument until all arguments are provided. So suppose we need to add three numbers, right? So suppose this is a function to add three. This is without currying how it would look. You will take in three parameters a, b, and c, and then we will return this as then return a plus b plus c. And then at the time of calling, what we are going to do is uh, we pass in 1 comma 2 comma 3. So this will go here, and then instead uh, this will be assigned here, and then the sum or the currying function will be returned. Okay, now let's see so now this is without currying. Now let's see with currying. Let's see. And this is with now with currying we would only have one parameter being passed. Now but we need three parameters, right? So if I have a function here, say function, okay, now this variable a is basically declared in the scope of this, right? So this variable is present over here. So even if so since this is an object and it's in the heap, right? So even if since it's not declared in here, this inner function can access that, right? So a will we can get that thing from the outer scope, right? Because it's present here and this function is in this function scope, so we will be able to access that. Okay, uh, no, I just needed to erase this. No, Now we already have web. Similarly, what we can do is we can pass in another parameter here, right? Saying that okay, let's have b. So if there is a function inside, since that will be present in its scope, it will be able to um, it will be able to access both a and b, right? And then what we need is we only need a parameter c, right? Which kind of uh, does, and then we can add our a and b and c, right? So why this is happening? Because remember, so this a is going to be present here, and this will be remain in the memory, right? The code will be still present even though we don't reach here. It is still present in the heap because these are higher objects, right? First class citizens. So whatever is the scope, it's still being kept in here because it's the reference is still there. And till the innermost, so when we come in the innermost, the outer this will be still be there because there is an inner function which is retaining this scope or retaining the reference to here. So now how we are going to call this? So what is going to happen is, so first we are going to come this, and then we are going to return this function, that is return func b. So first is let's pass a. So let's say how are we going to so what happens when we call this? So let's say without, so with currying this is, so you call this. Now let's pass in, say let's pass in let's pass in 1. So now here this 1 is going to come here, and the moment I reach this, what I'm going to do is I'm going to this is going to have a return value, right? This is basically returning this function. So if you assign this to a variable, it will get, you will get this sorry, you will get this inner func b, right? So you will get this one. So now using that variable, we can again make a call and pass in 2, right? So now this will go here, and we are returning this. So that return reference is still going to be stored in another variable, and using that you can pass another value 3. So now that is going to see. Now, but what is going to happen is, since this statement has not been worked, right? So this access is still not lost. The moment I lose this access, this function execution is done, right? So but since this is the innermost, the or like when we try to execute this will be present in the heap, and so will be the outer. So whatever the local variables are will still be maintained. Hence, instead of making multiple calls, you can do a simple call. Okay, so basically reusable, right? You can make, I mean, you can, so you can, instead of passing everything in one time, you can, debugging becomes more easy, right? You can have partial values being returned. For example, you need to check the state or something like that if there is any issue with your code. Now let's write down some code. Let's have a script.js. The first thing is we're going to define our function, and this is with string, and then we pass in the, and then and we return another function. So these are anonymous functions. So then you do then you return something called as another function. So return another function, right? Yeah, so let's return another function. This is C. Oh, I missed FUNC. And then let's have another parameter, like A, B, and then let's return A plus B plus C. Now let's see, let's call let's just do console dot of. Okay, let's assign that function, no? So the variable one is, so we are going to call with curring, right? So let's pass an inside. Let's have variable one being called here. Okay, let's open terminal. Let's try to. I already have node present here, so let's just run this into node script.js. Oh, so you got this function, right? Anonymous, because it's printing here. So now again, we're going to make a call c2, and then let's store this in another variable. So let's have this variable 3, and then let's console log variable 2, so we know like what are we exactly doing. So do console dot log of variable. Okay, let's have 2 be printed. Now let's see. So these both will have two functions, right? That is group that are returning. Now my variable, let's have another variable. This is variable 3. Let this be equal to now I'm going to call my variable 2 and pass a number to it, right? So I pass 10 to, and now do console. Let's try to see what happens here. Do variable 3, and then so you're getting 15, right? So 10, 2, and 3. So at each step you're returning. So this is the first outer thing that is. What if we you can do with arrow as well, but the moment we name it, so this is, you can name it as well. So let's this have inner, that this is innermost. So while calling, I guess no, but we're assigning it to. The thing is, we are using variable as an expression, right? So I guess, so first is we got the inner, and then we got the innermost, and then we got 15. So this is how and why we can do. So any language where functions are first class citizen, right? You can take that advantage, and then you can perform function currying, right? So And basically this is how function calling will work. And this is why, because the heap kind of retains, right, until the reference is lost, is not lost, the that is going to be stored, right? And then so these are all in the local scope of this, right? So that reference will still be maintained, and then GC won't come. um, as they are in heap, so that is one advantage, right? So that GC will come into play only when the reference is lost. So the moment the execution is completed over here, the inner references will not be needed, right? So as long as the inner functions are still working, the outer references still will maintain. Okay. So yeah, that's what I wanted to say. So even in this example, the way the because this function is still in under, so we said that this once the execution is completed of the outer, the inner reference will be lost and will be done GC collected, because now the outer can, so we cannot access the inner, right, without the outer's permission. So I guess that is all for this lecture. I'll see you guys in the next one. Till that time, take care. Bye bye.